Hari Om. Hello everyone, I am Sri Jyoti. Welcome to my channel. Today's video is Permutations and Combinations Part 2. So make sure that you have watched Part 1. Today we are going to study about permutations when some of the objects are similar. See, in last class we studied that what is the number of permutations when n different objects. Okay, so taken r at a time. Okay, so here what is the number of permutations when some of the objects are similar or some of the objects are repeating. Okay, see, in last class we took the example number, right? See, here all the objects are different, right? So what is the number of permutations? Number of permutations when different n objects, okay, n different objects taken r at a time is n factorial divided by n minus r factorial. Isn't it? That is NPR. N factorial divided by n minus r factorial. Okay. So here and here repetition is not allowed. If repetition is allowed, what is the number of permutations? N raised to r. Okay. Now here when some of the objects are similar, what is the number of permutations? See here, for example, mathematics. Okay. See here, A is repeating, right? A is repeating 2 times. M is repeating 2 times. So, in this case, what is the number of permutations? Now, let us see the number of permutations when permutations of n objects taken all at a time. Okay, taken all at a time when p of them are similar of one kind and q of them are similar of another kind. Okay, and remaining of them are different is given by n factorial divided by p factorial into q factorial. Okay, see, remember this formula. When it is the number of permutations when n objects, okay, with n objects taken all at a time, when, see, p of them are similar of one kind. Okay, p of them, some objects are repeating, that is some objects are similar. Okay, so p of them are similar of one kind, that is number of repeating words, okay, repeating objects. Okay, so and q of them are another kind of similar of another kind and remaining are different, then number of permutations is n factorial divided by p factorial into q factorial. Okay, remember, if what is the number of permutations when n different objects are taken r at a time? N factorial divided by n minus r factorial. Isn't it? So here the number of permutations when some of the objects are similar, n factorial divided by p factorial into q factorial. P of them are similar of one kind, q of them are similar of another kind. Okay, so here, okay, based on this, let us do solve some word problems. Look at first question. How many 3 digits numbers can be formed by using the digits 1 to 9 if no digit is repeated. Here, see, we have to find the number of permutations. Okay, the digits from 1 to 9 are different, isn't it? 1 to 9, 1, 2, 3, etc. up to 9. Okay, so 1 to 9 are different and taken 3 digits at a time, and repetition is not allowed. So what is the number of permutations? Number of permutations of n different objects taken r at a time and repetition is not allowed is npr, that is equal to n factorial divided by n minus r factorial. Isn't it? So what is n here? How many digits? 9 digits. 1 to 9, 9 digits. 9 factorial divided by 9 minus 3 factorial, right? R is 3. 3 at a time. Okay. We have to write 3 digits. So in how many ways we can write 3 digits from 1 to 9 digits? Okay. So here we applied the formula, permutation formula, NPR, n factorial divided by n minus r factorial. So see, be careful about this. Here it is mentioned no digit is repeated. Okay, that means repetition is not allowed. If repetition is allowed, so what is the formula? N raised to r. Here no digit is repeated. Okay, that is repetition is not allowed. Therefore the formula is n factorial divided by n minus r factorial. Okay, so 9 factorial divided by 6 factorial. So we can write 9 factorial as 9 into 8 into 7 into 6 factorial, isn't it? Divided by 6 factorial. So that we can cancel 6 factorial. That is equal to 9 into 8 into 7. That is equal to 504. Okay. So in how many ways? In 504 ways we can write 3-digit numbers from the digits 1 to 9. With the repetition is not allowed. Okay. Next question. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Repetition is not allowed. Okay. So, how many digits? 6 digits, right? 1, 2, 3, 4, 5, 6. Okay. So, there are 6 digits. So, total digits 6. Okay. Number of digits 6. And here, see, we have to write 3-digit even numbers. Okay. 3-digit even numbers. So, here, okay, let us do it, solve it directly. Okay. See, we have to write all, not all, even 3-digit numbers, right? Okay. So, first, let us go through first unit place. Okay, so it is the unit, tens place, hundreds place, right? So in unit place, see, this unit place can be filled with either 2 or 4 or 6. Why? Because even numbers, right? We have to write 3-digit even numbers. So our question is, in how many ways we can write 3-digit even numbers using these digits? Okay, these 6 digits. So here for even numbers, the first unit place, okay, unit place is filled with either 2 or 4. Okay, what are the even numbers here? 2, 4, 6. So we can fill this with either 2 or 6 or 4 or 6. So in how many ways we can fill this unit place? In 3 ways, right? In 3 ways we can fill this unit place. Okay. And see, repetition is not allowed. Okay. And what about tens place? Repetition is not allowed. So we have already written 1 digit. Okay. So remaining 5 digits. Right. So in 5 digits, see, in how many ways we can fill this tens place? See, we can fill this tens place in 5 ways, right? In 5 ways. Isn't it? Because remaining 5 digits. And here, in hundreds place, here we have already written 2 digits and repetition is not allowed. It is mentioned already. No digit is repeated. That is, repetition is not allowed. Okay. So here, in how many ways we can fill this hundreds place? In 4 ways, right? 4 digits are remained. So here in 4 ways we can fill this hundreds place. Okay. So what is the total number of permutations? Total number of permutations 4 into 5 into 3. Okay. That is 20 into 3, 60. Okay. So in 60 ways we can write 3-digit even numbers from the digits 1, 2, 3, 4, 6, 7. Okay. So here you can solve this using formula also. See what to do. First you will find the permutation of this unit place. Okay. See what is the permutation of unit place. See unit place is, okay, here 3 digits, okay, from 3 digits, that is 3p1. Okay. And writing either 2 or 4 or 6, right? Taken one at a time, one digit at a time. Okay. From 3 digits, see 246, from 246 taken one digit at a time. Okay. So 3p1, 3 factorial divided by 2 factorial, you will get 3. Okay. And next you will find these two. Okay. These 2 digits and 5 digits. Okay. From 5 digits you have taken 2 at a time. Okay. Because next you will find the number of permutations of these two. Okay. Tens place and hundreds place. Okay. It is better to do this method. We can do it directly. Okay. So 4 into 5 into 3 is equal to 60. In 60 ways we can write 3-digit even numbers from the digits 1, 2, 3, 4, 6, 7. Okay. See, if you want to apply permutation formula, then first do this one. Okay. Find number of permutations of first place, that is unit place, from 3 digits. Okay. Taken one at a time, one digit at a time, because we have to write only one digit. Okay. We will first we will find the permutation of first unit place. Okay. After that you will find 2 places, that is tens place and hundreds place. That is from 5 digits. Okay. We have already written one digit. Okay. And 5 digits are remained. Okay. Because repetition is not allowed. So from 5 digits taking 2 at a time. Okay. Taken 2 at a time. So permutation is 5p2. Okay. Then find, then after that multiply. Okay. So it is better to in this method. Next question. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? See here total number of persons 8, right? See, and we have to choose 2 persons, right? One is a chairman and a vice chairman. Okay. And see during solving the problems, you have to read the question carefully. Okay. See, because before going to apply the formula, see, you should know if the repetition is allowed or not, right? See, here it is mentioned that assuming one person cannot hold more than one position, that means repetition is not allowed. Okay. Repetition is not allowed. So what is the formula? Total number of persons 8. Okay. That is when n different objects, persons are different, right? Okay. N different objects taking r at a time and repetition is not allowed. What is the number of permutations? What is the number of ways to choose? That is npr, n factorial divided by n minus r factorial, right? So here total number of persons 8, right? And we have to choose 2 persons, right? Now, what is the number of permutations? Number of permutation is equal to NPR. right? That is, what is n here? 8. P, what is r? 2, right? That is 8 factorial divided by 8 minus 2 factorial. N factorial divided by n minus r factorial. Okay? N factorial divided by n minus r factorial. So 8 factorial divided by 8 minus 2 factorial, that is equal to 8 factorial divided by 6 factorial, right? So we can write 8 into 7 into 6 factorial divided by 6 factorial. 6 factorial is cancelled. So 8 into 7, 56. So what is the answer? In 56 ways we can choose a chairman and a vice chairman from 8 persons without repeating. Okay, that is without hold more than one position. Okay, a person cannot hold more than one position. Okay. Next question is, how many words with or without meaning can be formed using all the letters of the word equation using each letter exactly once? Okay. See here we have to write some words. We have to write all the words. Okay. Using all the letters of the word from the word equation. Okay. We have to write, see, we have to use all the letters from the word equation. Okay. See this equation, all the letters are different, isn't it? All the objects are different. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 objects, 8 letters are there. So we have to write 8 letter words from the word equation. So what is the permutation? That means in how many ways we can write 8 letter words from the word equation. Okay, and one more thing. See, it is mentioned that using each letter exactly once. See, in many ways they will mention about repetition. Okay, so that's why I told when you read the question you should be careful. Okay, see here it is given that using each letter exactly once. Exactly once means no letters should not be repeated. Repetition is not allowed. Okay, so what is the formula? So here n different objects taken all at a time, isn't it? Taken all at a time. Why? Because it is given using all the letters. We have to form the word using all the letters of the word. Means all the letters means 8 letters, right? So what is the formula? Number of permutations is equal to number of objects 8, right? Total number of objects 8, that is letters 8. P taken all at a time 8 letters. Okay, R at taken R at a time, R is nothing but 8. Okay, so 8P 8, that is equal to, and repetition is not allowed. So what is the formula? N factorial divided by n minus R factorial, right? That is 8 factorial divided by 8 minus 8 factorial. Okay, that is equal to 8 factorial divided by 0 factorial. 0 factorial is nothing but 1, so it is equal to 8 factorial. Remember, 0 factorial is 1. So answer is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Multiply, so we will get 403320. Okay, 40,320. Next question is, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Second, vowels are all together. Okay, so first of all let us go through first one. So here, see, given word is permutations. Okay, and how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So 12 letters. Our first question is, see, we have to write the words. In how many ways we can write the letters, words, start with P and end with S. So all the words should be start with the P and end with S. So here, let us take P and X fixed. Okay, P and X fixed. So we have to arrange on only the letters between P and S, right? So only the letters P and S. See, we have to arrange only these letters. So how many letters? Total 10 letters, right? So we will arrange these 10 letters. So what is the formula? See, first one. See, before that, you have to check whether any letters are repeated or not. Okay, that you should not be forget. See here, how many letters are repeating? See, T is repeated twice. Okay, so according to that, you have to apply the formula, isn't it? So here, first of all, you have to check whether any letters are repeated or not. Okay, for that, here let us write number of permutations. Number of permutations is equal to, see, it's little complicated. Okay, no problem. See, you should practice. Okay, you should take many exercise problems, solve many exercise problems. You will get it very quickly. Okay, so here, first of all, words start with P and end with S. So we have to write all the words start with P and end with S. So we have to arrange all the letters in between P and S. So in between P and S, 10 letters are there. And 2 letters, that is only T, okay? T is repeated twice. Only T. No other letters are repeating except T, isn't it? See, all the letters are different except T. So T is repeated twice. So what is the formula? N factorial divided by P factorial into Q factorial. Okay. That is when some of the objects are similar. Okay. Now here, what is the number of permutations? 10 factorial. Here P and S are fixed. Okay. So here we are arranging the letters between P and S. So 10 factorial. So 10 letters are there. 10 factorial divided by T repeated twice. So 2 factorial. Okay. That is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial. Okay. So that 2 factorial will cancel. So 2 factorial cancelled. So answer is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3. Okay. Over. So after multiplying you will get 18,14,400. 18,14,400. Okay. So next one. Let us go through next one. Second. So I hope you understood this. Okay. So let us go through next one. Vowels are all together. So here we have to write the words. We have to write the words with the vowels should be come together. Okay. That is, for example, one word I will write. See how many vowels are there? 1, 2, 3, 4, 5. Okay. So 5 vowels. I will write one word. Okay. P, R, M, E, U, A, I, O, T, T, N, S. I hope I wrote all the letters. Okay. So here, see, for one example I gave. See here, I have written all the vowels together. So in such a case, okay, in such a case, in how many ways we can write the letters? We can write the words with all vowels should be together. Okay. So here, first, here vowels also. Let it keep here. Okay. So first, see, we can arrange these vowels also. Right. So in how many ways we can arrange these vowels? See, sometimes this will come here. Okay, E, I, O. Okay, sometimes this will come here. I, A, O. So, in how many ways we can arrange the vowels? So, that also first we will find. So, here, first of all, we will find the number of permutations of vowels together. Okay, number of permutations of vowels. Number of permutations of vowels together. That is, how many vowels are there? 5. Okay, so we have to arrange this. Okay, so here 5. So what is the number of permutations? 5 P 5. Okay, that is 5 factorial divided by 0 factorial, that is equal to, that means 5 minus 5 factorial. So 5 into, it is 1, so 5 into 4 into 3 into 2 into 1, that is 120, right? 5 into 4, 20, 60, 120. Okay. So now it is 120. So now we have found what is the number of permutations of vowels. Okay. This one we have found. Next, after arranging this one, we have to arrange these letters also. Right? So this will come here or come here. Okay. So whatever. So we have to arrange these letters. So next we will find the permutations of those letters. Okay. So for that, let us take these vowels. Okay. These vowels, take these vowels as one letter. Okay. These vowels as one letter. Take these vowels as one letter, because in all the words, vowels should be together. Right? Vowels should be together. So let us consider these vowels be one letter. Okay, then what is the number of letters? See here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so take this as 1. So 1, 2, 3, 4, 5, 6, 7, 8. Right? So we have to write 8. We have to write the words from 8 letters. Okay, from 8 letters. So taken all at a time. Okay, we have to write all the letters, right? Isn't it? We have to write the words from all the letters, using all the letters of these permutations, right? So here, next we will find the number of permutations. Taking vowels as one letter, okay? So what is the permutation? Here total how many letters? 8 letters, because we have taken this as one letter. So 8 letters. So 8 factorial divided by 8 minus 8, because here n objects taken all at a time. Okay, because we have to write the letters, words using all the letters of the word, right? So all at a time. So divided by 0 factorial. Means 8 minus 8 factorial. Okay, that is 8 factorial, that is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That is nothing but 20,160. Okay, now we have got 2 permutations, right? Next, see, we have to find the total number of permutations of words. Okay, vowels are all together. So in how many ways we can write the words from permutations be arranged when vowels are all together? That is 120 into 20,160. So total number of, here I will write, okay, total number of permutations permutations is equal to 20,160 into 120. Okay, that is 2419200. Okay, so in this ways, in 24,19,200 ways, we can write the words when vowels are all together from the word permutations. Okay. Let us go through next question. How many 6-digit telephone numbers can be constructed with digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? If each number starts with 35 and no digit appears more than once. Okay. So here total number of digits 10, and we have to construct numbers starting with 35. We have to construct 6-digit numbers. Okay. We have to construct 6-digit numbers. So starting, all the numbers start with 35. Okay, so it is fixed. So 35, starting number 35, it is fixed. So we have to arrange only these 4 places, right? And 35 already written. It is mentioned that no digit appears more than once. So no numbers should be repeated. Okay, so here 35 already occupied. Okay, and see, we have to arrange only these 4 places from how many numbers except 3, 5. So how many digits? 1, 2, 3. Yeah, total 10 numbers minus 2, that is 8. Right? From 8 digits we have to arrange these 4 places. Isn't it? Because it is mentioned that all the numbers should be start with 35. Okay, so we have to arrange these 4 places from 8 digits. 2 digits already written and no letters or no numbers should be repeated. Okay, repetition is not allowed. Therefore, see what is the permutations. So here we have 2 permutations of only this, right? Only 4 places, that is n objects. Here 8 objects taken 4 at a time. Okay, 8 objects, 8 letters taken 4 at a time. So what is the permutations? And the repetition is not allowed. So number of permutations is equal to number of permutations is equal to 8p4, right? Because here it is fixed. In all the numbers 35 is fixed. So we have to arrange only these 4 places. So from 8 objects, okay, from 8 digits except 3 and 5, okay. So total there are 10 digits except 3 and 5 already written, okay. That is that come in first, right, first place. Okay, so after that 8 digits are remained. So we have to arrange 4 places from 8 digits. So what is the number of permutations? Number of permutations is equal to 8p4. Okay, 8 digits from 4 digits from 8 digits. Okay, so here 8 digits taken 4 at a time. So remember, and here no digit is repeated. That is, repetition is not allowed. So what is the formula? N factorial divided by n minus r factorial, that is 8 factorial divided by 8 minus 4 factorial, that is 8 factorial divided by 4 factorial, that is 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial, that is equal to 4 factorial cancelled. Okay, so 8 into 7 into 6 into 5, 6 into 5 is 30. So 8 into 30 into 7 into 8, that is 7 3s are 21. Next into 8, that is 80, 81, 60. Okay, so 1680. Okay, so in how many ways we can arrange these telephone numbers? 6-digit telephone numbers with the 35 as the first. Okay, so here 1000 in 1680 ways we can arrange 6-digit telephone number start with 35.